recording for math analysis notes on section 02. This is part 1. Excuse me, of a two-part. There will be two recordings for this. This is 02, operations with complex numbers. My expectation is that you are writing this heading 02, operations with complex numbers. And for chapter 0, you only have to write the heading. You don't have to write the objectives or anything, but we'll add to that the next time. Generally, I'll write in yellow as kind of just a way to highlight something or point something out, and then I will move on from there. So this is, our objectives are to perform operations with pure imaginary numbers and complex numbers, and then to use complex conjugates to write quotients of complex numbers in standard form. I'm hoping to get all of 1 done. We'll see if that happens. So our new vocabulary is the imaginary unit, complex number, standard form, the real part and imaginary part, an imaginary number, a pure imaginary number, and complex conjugates. And I'm just gonna, I'm going to add a slide here, so if you need to pause that to write your heading, go ahead. I'm going to add a slide, and we're just going to kind of mull over kind of I and things like that. So I'm just going to remind you, you've had this before, but I is equal to the square root of -1. And so you should probably, you know, write that down. And we can also say that's I to the first, that's like I to the first is the square root of -1. So remember, anything to the 0 is equal to 1. So I to the 0 is equal to 1. And what we're going to do is we're just going to kind of make a little chart that gives us different powers of i's and kind of look at what is happening there. And so I'm going to go down vertically here. So I'm just going to rewrite I to the 0 is 1, because anything to the 0 is 1. I to the 1 is, we're just going to call it I for now. I know it's the square root of -1 as we go. So then I squared is the square root of -1, because that's what I was, raised to the second. And so when we square that, the squaring and square rooting cancel each other, and so we get -1. And then I to the third, I'm actually going to think of I to the third as I to the first times I to the second. And so I to the first is I, and I to the second is -1. And so what that's going to mean then really is that I have I times -1, or -I is I to the third. Then I to the fourth is, this time I can break that into, you know, any powers of I, but I'm going to say it's I squared times I squared, because I think that would be easy. And then just a reminder, I squared is -1, so that's going to be -1 times -1. And so that's what we'll get there then. -1 times -1, which is +1. And now, so notice here, just make that note to yourself, that I to the 0 and I to the fourth are both equal to 1. Well, let's do a couple more powers of I, just to kind of see what's happening here. So I will go back to my red though. I to the fifth. Let's think of that, because I to the fourth is an easy way to kind of think of things. Let's think of that as I to the fourth times I. Well, we just said I to the fourth is 1, so this is 1 times I, which is still I. And now let's do I to the sixth. That is like I to the fourth times I squared. Let's think of that way. And so I to the fourth we know is 1, and I squared we know is -1. And so I to the fourth times I squared is going to be +1 times -1. And let me get rid of some of that yellow. And so that is +1 times -1. So that is -1 as we look at that. Then I to the 7th. I'm going to use I to the 4th again because I to the 4th is an easy power to use. And then times I to the 3rd. And then I'm going to look above here. I to the 4th is 1. I to the 3rd is -I. So it'll be 1 times -I, which is -I. And we'll just do one more to see what happens here. I to the 8th. And that I'm going to pick to say I to the 4th is I to the 4th times I to the 4th. And I to the 4th is 1. So it's 1 times 1. Which is 1. So make a note to yourself of some things that are happening. I to the 0 was 1, I to the 4th is 1, I to the 8th is 1, and then look at that pattern afterwards. So we have our 1, then we have I, -1, -I. We have our 1 again, then we have I, -1, and -I. And then this one is 1, so we can say, oh, I to the 9th is just going to be I again. So I to the 9th is going to be I, and we can just kind of keep going on with that pattern. So if you think about the powers of I, every time you get I to the 4th, then let me get rid of some of that yellow stuff. Every time we have a multiple of I to the 4th, it's going to equal 1. And not only that, but it's repeating kind of every time after like 4 answers, then it just repeats itself. So what you want to think of is the multiples of the powers of 4, and then we can just see what that remainder is as we go. So let's say I had I to the 15th. Well, in my head, I'm going to say 4 goes into 15 3 times, and that's 12. And then there's a remainder of 3. And so I could say this is I to the 12th times I to the 3rd. And so I to the 12th is just 1. And I to the 3rd is -I. So I to the 15th is -I. And so really in my head, the way that I do it is I take this 15, I divide it by 4, and that's 3, and this is 12, and the remainder is 3. So then you look at the remainder, because that really doesn't matter how many times it goes, it's what the remainder is. And if the remainder is 3, I get -I. If the remainder is 2, I get -1. If the remainder is 1, I get plain old I. And if there's no remainder, I get 1 as we go. So that's how I would approach positive powers of I. Now, negative powers, and you're going to see, and the book authors kind of have a way of going through this, you're going to see that they do it a little differently than I do. But in my mind, it's hard for me to remember all of these remainders. So I just look at those powers as negative, and then I just kind of use the reciprocal. So if I have I to the -2, oh, I'm sorry, I didn't do I to the -1. So we also know I to the 0 was 1. So I to the -1 is 1 over I. But then we have to rationalize the denominator. So I'm going to multiply by I over I. And when I do that, I'm going to get I over I squared. I squared is -1. And so then I'm going to get, oh, just a minute. I'll get I over -1. Let me just pause a moment. And that will be negative I. And then I to the -2 is 1 over I squared. And I'll rationalize that by just I'll rationalize that by just putting what I squared is, and that's -1. So I'll get 1 over, I'll just write it in another color, -1. And so then that's -1. I to the -3 is 1 over I to the third. So that's how I do these problems as we go. And I remember that I to the third is -I. So that's 1 over -I. And then I do have to rationalize that denominator by multiplying by I over I. I don't know why I put it in parentheses that time. And then this negative can just go out in front if I want, and that's I over I squared. I squared is negative again, so that's -I over I squared, which is -1. And so then I to the -3 is positive I. So my method for this situation of negatives is a little cumbersome, but once I get those kind of figured out, then it's pretty smooth sailing for me as I go. I to the -4, I will just do that as 1 over I to the 4th. Remember, I to the 4th is 1, so that's just 1 over 1. And so that is equal to 1. And that's just my little like reminder or explanation of how to handle I. I just do it in that manner. The book authors here have a kind of different thing. It's hard for me to remember this as we go. So take a minute, just write down the imaginary unit I is the principal square root of -1, and it can be written I equals -1. So add that to your notes as you go. There's some powers of I there as well. And if you need to pause this, go ahead, and then I'm going to just slide down so that I can see the rest of this slide. So the book authors give this information about the powers of I, and I'll just leave that there for you right now. And if you need to pause this, you can, if you want to do it this way. To me, that's just it's a little bit hard to exactly follow, but I'll leave that for you as you go. And then we'll move on and kind of look at a couple of problems here. And I maybe should have, if I had time in my life, kind of change this up a little bit, but that's okay. So let's just kind of clean that up and just make more white space there for myself. So that makes me happy to have white space. And so I'll go over kind of my method of doing these. So this is 1A, and it's I to the 53rd. Really, I'm just going to take 53 and divide it by 4 because I know there's those 4 repetitions. And this goes in there once. This goes in there 3, and that's 12. So my remainder is 1. That's what kind of tells me what that is. And so I can either think of that as I to the 4 times 13, which would be 52 times I to the 1. So this is 1 times I, which is I. Or I can just remember that that was a remainder of 1 and say I to the 53rd is equal to I to that remainder, which is 1, and get I that way. Whatever method works for you is fine with me as we go. Then, and pause that if you need to write down more. Then I'm going to go on to this next one. For me, I probably do this a little different than both of those methods, but I to the -18 is, the way I do it is 1 over I to the 18, and then I just do my same thing. 18, I'll divide that by 4. That goes in there 4 times 16. The remainder is 2. So this is 1 over I squared. And I squared is -1. So 1 over -1, which is -1. That's my method. If you use other things as well, you certainly can. Now, the next thing is we want to just get some vocabulary under our belts so that we're kind of used to saying things like standard form, the imaginary number, the pure imaginary number, the real part, the imaginary part. So I'll just underline and you can write, or maybe I will write some things here. So a complex number is written as A plus BI, where I forgot the H and where, sorry, where A is the real part and B is the imaginary part. The imaginary part. So maybe that's just a little more concise. You might want to, and I'll just put a yellow box around that because I don't want to add to it. But so the real numbers are a huge set, it's infinite, and the imaginary numbers are huge as well, and the pure imaginary numbers are huge, and then that whole thing makes our complex number system. And so if we have this A plus BI, let me just kind of go and do this. So this next little part is also A plus, let me just do this A plus BI. So if A plus BI has A as a number but B is 0, so if B is 0, A plus 0I, which is just A, that's going to be real, a real number. And so real numbers are considered complex numbers, even though, you know, we kind of think of them in their own little thing. And then if I have A plus BI, where it just kind of stays that way, that's an imaginary number, imaginary number. And then if I have A plus BI where A is 0, so I just end up with the BI part, I'll go 0 plus BI, which is BI. That is called a pure imaginary number. So just a little bit of just making sure that as we move on in mathematics, you know, we kind of get a little better versed with how things are going and terminology, I guess. If you need to pause this, go ahead. I'm moving along. And then we have a couple of problems. The nice thing about complex numbers is, you know, even though they are leading us into, you know, kind of transcendental numbers, which you haven't had yet. But and I'm sorry, I'm just taking a moment and making more white space on my slides for myself. But they do operate a lot like a variable, like, you know, 5 plus 3x plus 2 minus 4x, and that's something that we're familiar with. So 2a, notice this, these are complex numbers, so they're kind of in their little parenthesis. We get 5 minus 3i, plus parentheses negative 2 plus 4i. And then I'm going to kind of do this as a two-step problem. I'm going to drop my parentheses in my head. I'm going to kind of use the commutative property and put the real parts together and the imaginary parts together. But I can write this as 5 minus 3i plus negative 2 plus 4i. So essentially, I just dropped that. I could have made the plus negative 2 into just minus 2. And then I'm just going to do kind of the arithmetic. I could group the, like use the commutative property and just rewrite that whole thing as 5 plus negative 2 plus, I'll put it as negative 3i plus 4i, and then I have them kind of together. Or, we've done enough math that maybe we can just kind of keep them like that. 5 minus 2 is 3. Minus 3i plus 4i is plus i. And ta-da, we're done. So you might be thinking, oh, but Mrs. Jones, I don't need to write all that. I can just go from the problem to the answer on that one. And I'm like, awesome. Go ahead and do that. And but when you get down to this next one, which is a subtraction problem, I say caution, 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 because this is where we kind of lose things and make some mistakes. So 2b, write this down, parentheses 10 minus 2i minus parentheses 14 minus 6i. And why don't you just maybe pause this recording right now and just try that one and just see what you get, and then we'll kind of compare it. So if you did that, now I'm going to kind of go over it. So I'm going to go through this same process. So I'm going to drop that. That's 10 minus 2i. But here I'm going to distribute this negative sign through there. And when I write this part, I'm going to write that that's minus 14. Most people do that, but. Then it's minus negative 6i, so we have to change that into plus 6i. This is the place that we sometimes get into trouble, and we have to just be super cautious. Then we'll go through and say, oh, 10 minus 14 is negative 4. Negative 2i plus 6i is plus 4i, and voila. We have the answer. I hope you did well on that one as you went. Then we can look at the distributive property, and we do want to remember that we have that I squared when we use the distributive property. Now, just from some things I've learned over time, I often just use the distributive property instead of kind of commenting on FOIL. If you've used FOIL, I used to talk about FOIL all the time in my classrooms, but now I just kind of say distributive property. And so if you remember the distributive property, 5 times 3x minus 2, I multiply 5 times 3x, that would be 15x, 5 times negative 2 minus 10, and that is the distributive property. Well, when I have two binomials, two-term things, I go 2 minus 3i times 7 minus 4i. Well, what I'm going to really do here is I'm going to take that first 2, and I'm going to distribute it times each of those. I forgot to put that little parenthesis there. And then I'm going to, next, I'll use just a different color. I'm going to go to that with that negative 3i and distribute it to the back part there. So, it turns out to be kind of the same as the FOIL, but when we consider it distributive property, it moves itself to other longer things. What if it's 3 terms times 4 terms? How are we going to handle that if all we know is that FOIL thing? So I'll just write in some black arrows here. 2 times 7 is 14. 2 times negative 4i is minus 8i. And then I'll do the same thing with the negative 3i. I'll multiply it times 7 and then times negative 4. So negative 3i times 7 is minus 21i. Oops, 21i. that did not turn out well still. And then negative 3i times negative 4i is plus 12i squared. So again, you know, as we're looking at this, this is I squared. We can't leave that alone. We have to change it based on what it is equivalent to. And I'm gonna just do a little bit of side work. And sometimes I call these think boxes. So this is my think box. I'm going to say this is plus 12i squared. I'm going to remind myself that I squared is negative 1. So instead of plus 12i squared, I'm going to say it's plain old minus 12. And I'll just rewrite it that way just because this is my notes and I want to kind of just remember what's happening there, and then that'll be minus 12. To be super honest, a lot of times I'll write this row that's right here, and then I'll just cross that out and go minus 12 instead. But this is our notes, so we want to kind of write ourselves things that we'll be able to recognize and follow later on. So 14 minus 12 is 2. Minus 8i minus 21i is minus 29i, and that one's simplified. So maybe take a moment if you want, and this is 3b, and see if you can do this one yourself. So 4 plus 5i times 4 minus 5i. And same thing, if you want to pause this and try it, and then I'll go over it in just a moment here. So if you've paused it, now I'm going to use that distributive property. So 4 times 4 is 16. 4 times the negative 5 in the back is minus 20i. 5i times 4 is actually plus 20i. And 5i times negative 5i is minus 25i squared. So two things going on here. One is that this is minus 20i and plus 20i. So we'll kind of scratch that out. And then I'm just going to do my little think box in my head. This is minus 25i squared. I squared is negative 1. So negative 25 times negative 1. I'm just going to cross it out and say it's plus 25. 16 plus 25 is 41, and that is done then also. Think about these, and do you remember what they are called? They have a special relationship. 4 plus 5i and 4 minus 5i. They are complex numbers, but when we multiply them, we get a real number. I may ask you what that is called on your Zoom tomorrow. So either look at that up or maybe not, but we'll see if we know what that is. Have a great rest of your day.